Hello again. In this part of the lecture today, we're going to be talking about bone formation, growth, and remodeling. This is going along with the idea that we've talked about before, that bones are not static, they're constantly changing. Have you ever thought of your bones as being, once you're done growing, your bones don't change anymore? That is definitely not the case. So your bones may not be actively getting longer anymore after your growth spurt is over, but your bones are always changing and reshaping and forming as you go throughout your life. First, we're going to talk about the relationship between hyaline cartilage and also bone. So our skeleton, all of us with a bony skeleton, we first started actually as a hyaline cartilage skeleton before we had a bony skeleton at all. So when you were in your mother's womb as an embryo, the first skeleton you had was not built out of bone, but built out of hyaline cartilage. And then during the time in the womb, as you grew and once you were born and you continued to grow, all that hyaline cartilage was replaced by bone. At this point, as an adult, there's very little hyaline cartilage left in your body, not even in your long bones. And we've talked a little bit about the epiphyseal plate, but your epiphyseal plate has also been replaced by bone. Your growth plate is now gone. So mainly the only places you have cartilage still are going to be in the bridge of your nose, parts of the ribs, and in your joints. So let's talk a little bit about how this happens. So in our last lectures, we were talking about the structure, the anatomy of bones. We mentioned the epiphyseal plates. All of the long bones, all the bones besides basically the flat bones, have epiphyseal. Because all of your bones besides the flat bones were built on a hyaline cartilage skeleton. So the way this works is that at the epiphyseal plate, new cartilage is continuously being formed, and it's elongating that bone. And as this cartilage is being formed, the bone is coming along behind it, and it's being ossified. So that means that the cartilage is being removed and is being replaced by this bony structure. As the cartilage is being replaced in the long bone during childhood, as this is growing, you also open up the medullary cavity. So when you have a hyaline cartilage skeleton, there's no medullary cavity. Remember, that is the opening in the middle of the bone. It's hyaline cartilage all the way through, but as the bone is replacing the cartilage, that medullary cavity opens up, and then the bone starts being put in place of the hyaline cartilage. Remember this word here. So here's that term we've talked about before. The term is osteoblast. Remember, osteo means bone, and blast is talking about the type of cell. Remember also that B stands for build. So osteoblasts are cells that build bone. And so it makes sense that the hyaline cartilage would be replaced using these osteoblasts to put in the bone. So here's some pictures showing how this happens here. So an embryo is the earliest point. So when you're an embryo, you're still in your mother's womb. You're just beginning to grow. In this picture here, the light blue part, that's the hyaline cartilage. And then we have the bone here. So notice how initially we have all this hyaline cartilage. In this picture here, the bone is starting to replace the hyaline cartilage. So you have this bone on the outside replacing, and then the osteoblasts here are going to come into the interior, and they're going to start replacing the hyaline cartilage here. Then after some time, Now you're no longer an embryo, you're now a fetus. This is farther along in the process, the gestational process, and still inside the mother's womb, your mother's womb. But notice how much the hyaline cartilage has now been replaced by bone. So now basically all we have is hyaline cartilage here at the ends of the bone. And the bone is starting to grow lengthwise. Notice how the medullary cavity has opened up. So you have this cavity in here. And notice also the blood supply. So remember, hyaline cartilage does not have a blood supply. Bone does. So when we have a mature bone, it's actively going to be supplied with blood throughout. And here we have the beginnings of arteries coming in and nourishing this bone. So as this bone is growing and replacing the hyaline cartilage and lengthening, that takes a lot of nourishment, it takes a lot of oxygen, so the blood is starting to inundate that bone and start that process working. Notice this little bit of bone here as well. So now we have the bone starting to replace the hyaline cartilage here in the ends of the bone as well. And then finally, as a young child, once you're born, you've been born and now you're still growing as a little child. Notice that at this point, almost all of the hyaline cartilage is gone. So by the time you're born, most of that hyaline cartilage skeleton is gone, and now it's been replaced by bone. But this process isn't done yet. It's continuing through childhood into adulthood. The main places that there's still hyaline cartilage is the articular cartilage, which we've talked about before. On both ends of the bone, we have this articular cartilage, which is going to be important in forming the joints. Notice that we have also the epiphyseal plate here, which is also cartilage. And so now the only places where we have bone actively new bone actively forming is here at the epiphyseal plate, and this is going to cause lengthwise growth. So the same process is happening here. So cartilage is going to be continually placed down, and behind it, bone is going to replace that hyaline cartilage, and as that happens, the bone is going to grow longer and longer and longer. The bone can also grow widthwise as well. This, however, does not require the hyaline cartilage to be placed down first. So the bone, we call this bone remodeling. We'll talk about this in a minute. This is lengthwise. This is width. The width of the bone is growing this way. So lengthwise growth is still carried out by the epiphyseal plates. These epiphyseal plates are going to stay intact until you reach adulthood, when growth stops, long bone lengthening stops. And so I shouldn't say that bone growth stops, because your bone is constantly changing, but lengthwise growth has stopped in adulthood. And what's going to happen is that epiphyseal plate is going to be totally replaced with bone, so it's no longer there, and your bone is all going to be, that hyaline cartilage is going to be gone. And that's how bone formation happens. Then there's also remodeling. Remodeling we call appositional growth. When it's growing in width, we call that appositional growth. And this can happen for a number of reasons. But remodeling of your bones, so what this means is that once you're done lengthening, your growth has stopped, remodeling can still happen. So remodeling happens throughout your life. It can happen in childhood, but then even after lengthwise growth is done, your bone can still be remodeled. The reasons your bone would be remodeled, first of all, is because of blood calcium levels. So remember that one of the functions of the skeletal system is to act as a storage place for minerals, especially calcium. Our blood has a certain calcium level. So if our blood calcium level gets too high, that means we have to remove that calcium from the blood. Calcium levels that are too high we call hypercalcemia. Hyper meaning a lot, and then calcemia meaning calcium. So hypercalcemia is when we have too much calcium. We've got to get rid of that calcium in the blood. If we leave that calcium in the blood, that can lead to a lot of problems. So what happens is the osteoblasts, or the bone, your bones are going to remove that calcium from your blood, and they're going to lay it down as calcium salts inside your bone. Same thing but the opposite situation, when your blood calcium level gets too low, Now the osteoclasts, remember osteoclasts are those cells that are going to break down bone, and so the osteoclasts, these large cells, start breaking down the bone, and that allows the calcium to go into the blood and keep your blood calcium levels where they need to be. So this happens throughout life. The other thing is the pull of gravity. So we can continue to strengthen our bones as we go through life, and as we work out and things like that, as we keep our body healthy, that's going to affect our bones as well. Not just our muscles, but our bones as well. So our bones have to be able to support our body. So any change in our body weight, in our strength, in the pull of our muscles is also going to affect our skeleton as well. As your muscles get stronger, they have to have a stronger bone in order to pull against, and so that's going to affect your bone growth as well. So let's look at this picture here. Let's first look at bone lengthening. So what we're looking at here in this picture is we can see your long bone. The dark blue portion here again is hyaline cartilage. So what happens in bone growth? Hyaline cartilage growth is going to happen at the top of this hyaline cartilage. So new hyaline cartilage is placed around the edges here and then on the top here. And so the hyaline cartilage is going to thicken. As this happens, new bone is going to be replaced below. So the bone is following along behind the hyaline cartilage. As this situation continues, this is going to cause the lengthening of the bone. So now here our bone has lengthened. So that is bone lengthening. Appositional growth, where the width of our bone is changing, what's happening in appositional growth, this is where the bone cells, so there's no hyaline cartilage involved at this point again, and what's going to happen is the osteoblasts and the osteoclasts are going to be involved in widening this bone. So if you think about this side of the bone here, this we want to increase in size so that it'll lengthen. So on this side, we're going to have osteoblasts laying down bone, and this is going to happen here as well. So osteoblasts are going to be laying down bone on the outside edges, and then on the inside, osteoclasts will start removing bone. And as this happens, so the osteoblasts laying down new bone on the outside, osteoclasts taking up bone on the inside, eventually this is going to lead to the widening of your bones over time. This is again called appositional growth. So that is how bone growth and remodeling works. Now let's look at what happens if your bone happens to break. So this is something that commonly happens. Our bones are amazingly strong for how light they are. So if you think about the weight of your body, so for example, the thing I was thinking about the other day, my little girl, she weighs maybe about 40 pounds. And if you think about a dumbbell, a steel or an iron dumbbell that weighs 40 pounds, that's very small. But my daughter, she's about, 3 or 4 feet tall, a lot bigger than this dumbbell. The dumbbell's maybe a 40-pound dumbbell would be about the size of her head and a little bit more maybe. But if we were to have an iron skeleton, that would be very strong, but also be very heavy. We'd weigh a lot more. But our bones, they're very light but very strong. And so it's a very good system that we have set up, but of course it can still break. So we get fractures in our bones and they break and things like that. So let's look at a few examples of fractures. So this picture here on the very left on the top, this is what a normal bone looks like. So you can break your bone in a lot of different ways. First of all, you can have what's called a simple fracture, and a simple fracture is when your bone breaks but that bone doesn't come through the skin. A compound fracture or an open fracture is when your bone breaks and it does poke through the skin. And then besides that, we have all these different types of breaks that can happen. We can have what's called a transverse break. So remember, we talked about a transverse plane. That's when you're cutting something straight across the middle. So it's just a nice clean break right through the middle. Oblique always means at an angle. So learning the word oblique will be useful when we talk about muscles. You've heard about maybe about your obliques if you like to weightlift and things like that or work out. You have your obliques. Those are muscles that go across at an angle. We have a spiral break. This is different than the oblique break, because in the spiral break it is caused by a twisting of your bones, of the bone. And so it comes at an angle here, but the edges are very ragged because it's twisting apart. We have a comminuted break, and this is when your bone breaks into more than two pieces. So look at all these small pieces that we have in here. It'd be a very, very bad break because it's very hard to fix. Segmental, we have a piece, so it's broken in two places. You have a piece in the middle. The other ones I want to look at is impacted. So an impacted is caused when the one bone is pushed in to the other bone, and it causes this impact fracture. And then the last one I want to mention is the green stick break. And this is when your bone doesn't break clear through. Often you may get these kind of splintery ends. And the reason it's called a green stick break is it's somewhat like a green tree branch being broken. So if you take a green tree branch, you try to break it in half. Because it's bendy, it's very hard to break that straight in half. So you may start to crack it, but you're not going to have a nice clean break. It's going to start fraying on the edges where it starts to break. You see this often in young children. Their bones are still soft, and so when that bone breaks, it makes this what we call the green stick break. I put some pictures over here, and if you look at these pictures, you can try to determine what type of break is being shown here. This one is a green stick break. So notice it doesn't go clear through. You often see this in the forearm. So my daughter this year, late last year, she fell on her arm, on her wrist, and she broke her forearm. And it was a green stick break. Still young, and so it looked very similar to this picture here. Young children, their bones fix very easily, and at this point, so her bone is healed and you can't tell that there was any break at all. So it's pretty amazing. Here we have a spiral break. Notice the angular break here, but then also the ragged edges. Here we have a comminuted break, and then here we have an impacted break, which is hard to see, but the arrows are pointing to where these bones have been pushed together. So these are different types of breaks that can happen. Breaks are a fact of life. They do happen, but our bones are very good at fixing breaks. So if you had a choice between breaking a bone or tearing a ligament or hurting a tendon or even hurting or tearing a muscle, choose breaking a bone. Because of this, bones heal. They have a system set up. There's a lot of blood, again, going into the bones, nourishing it. And so a bone is going to heal very easily. And in general, it's going to heal very well. The way a bone heals, first of all, at the break, you're going to have something called a hematoma that is going to... And this is basically the same as a blood clot. It's forming around where the break occurred. The next thing that's going to happen, you're going to have a callus forming of fibrocartilage. So remember, when we talked about tissue, we talked about fibrocartilage, which is it's a fibrous type of cartilage. And so we have many types of connective tissue coming in here and forming this kind of splint. So it's holding the bone fragments together. In this space in here, because the bone was broken, the bone cells that no longer have nourishment, they've been absorbed, and so now we have this callus that's forming. Next, we're going to have a bony callus formation, so that those connective tissues and the fibrocartilage are now going to be replaced by bone, going to be formed of spongy bone. And then over the next time period, few weeks, few months, depending on your age and how bad the break is, etc., etc., your bone is going to be replaced by compact bone, as the osteoblasts, osteoclasts are in here working away to reform that bone. Notice that we have all these blood vessels inundating here, nourishing this area, helping that bone reform. After that bone is healed, in an adult, often you'll have a kind of a larger area here in that bone where that bone break occurs. So if you look at an adult skeleton, you can find where those breaks occurred. If it's a young child, you're not really going to be left with any evidence, depending on the age of the child, but often you won't have any evidence of that bone break because this process works so well and the child was able to fix that bone easily, and so there's no remnants of that break left. So this has been our lecture on bone remodeling and growth.